will really expect you to have those.
Sorry about
No problem. Um, Certain kinds of careers will expect you to have accreditations or certifications, and we don't have any of those. We don't do that kind of work.
Especially in IA work. IA work, you really need your certifications. IR work, so incident response, the flyaway teams, a lot of that comes from practice. So figuring out what you see, the CTFs that you see are great. The Sandia and Lanel, Los Alamos National Labs have something called Tracer Fire. So it's a set of CTFs that they'll take away to universities and do on weekends and things like that. So that's kind of, that's kind of a cool experience if you get to do that. But like Chris said, find the thing that you want to do and try to go deep in that, whatever it is. For us, it's full stack. And, I have some networking buds that, really got into how does the switch work? How do I look for traffic? How do I use Snort? And how could Snort be abused that I have to understand to protect against that kind of traffic so that my firewall doesn't go down because somebody knew how to abuse it. But whatever you get into, whatever you want to do, if you can go deep in that, if you can go as deep as you can and sort of open up those black boxes and understand enough behind it that you can understand how they can go wrong, that will give you the foundation and structure to pivot almost anywhere else in cybersecurity.
Okay. Do any of you guys have any questions right now? Yes?
Yeah. Hi, I'm Aditya. Yeah, and you earlier mentioned binary or reversing engineering binaries. That's a topic that looked interesting to me in a couple of different projects, but it's such a broad field that how do you even get started with that?
Yeah, so that's a great question. It really, in my head, it goes back to what are you excited about? What are you interested in? So you do have to be a little bit careful. So there's an open source tool, a public tool that the National Security Agency has released called Ghidra. And that allows you, it's a framework for doing binary analysis of all sorts of different processor binaries. And unfortunately, a lot of the software that you might interact with on a daily basis might have an end user license agreement that says you will not reverse engineer their software. So I am going to tell you that it is legally questionable that certain things are. Some of them are like, yeah, go ahead and look at this all you want. Or you can take open source work like the Chromium browser or things like that, that you have the source and you can compile that and then import it into Ghidra and just start comparing what does the binary transformation look like based on the source code. I know a lot of people have gotten their start in as just hobbyists, like they wanted to understand how the Wii worked or how the Game Boy worked, and they made emulators for that sort of thing. So to make a cycle accurate emulator, you have to understand all of the hardware that's in the system, and you have to look at the processes, the binaries that are running. And so you can do that at a hobby level. You can find Reddit subreddits and Discord channels and servers, the things that are focused on that kind of hobbyist thing and get support that way. People are really open and friendly. They'll write blog reports. One place to look is Google Project Zero. They do a great job of security analysis and they write up really detailed blog reports. And so it's fun to read through those reports, but it's if you actually follow through and try to recreate what they're describing, you learn a ton. So I think if you can find something that really interests you and motivates you and just do it on your own, that is the best way.
Including game patches or things like, if you remember Doom, like people would take Doom and recompile it and run it in EFI in the pre-boot environment. So just rehosting actually gives you some of that, because in rehosting, you have to get down into the binary to figure out the bits of the hardware and the bits of the control that are different. But you can also search for just reverse engineering challenges. There are some little ones that will start, very tiny and sort of build up over time. They're kind of like capture the flag. But it's more focused on understanding rather than maybe extracting a key or something like that. So there's not as clear of a win condition. And Ghidra actually ships with some really nice training in how to use it, so you can start getting a sense of its features. There's also another tool called Binary Ninja. Binary Ninja has a student license for a couple hundred a year, something like that. And they have a very open API, a lot like Ghidra. They have a lot of tools and videos out. And then they have like monthly newsletters that are like, hey, here's something interesting or new, or a new tool that came out for Binja that you might be interested in following down. So even just joining their like, I'm interested in whatever you have to say club, you can get some little tips about reverse engineering from them. Radare is another open tool, another open reverse engineering tool. It's not as it's more programmatically friendly from the Python view. The the GUI is much worse, but you can do a lot more scripting around Radare interfaces if you want to.
Yeah, so that also, developing your own code and debugging your own code is how I got started. And if you're really comfortable with the debuggers like GDB or Windbag or LLDB, those will help you debug other code as well. So the experience is really the best teacher, and there are a lot of resources out there that you can ask, and people are really happy to join. You're a CTF group, right? You guys can work together and support each other as you learn. But I don't know. There's no there's maybe harder paths, but there's not an easy path. It's a lot of work and a lot of time.
Which is why you find something you like. Another thing that's really fun is looking at really old file systems and saying, can I find some really old file systems that, you know, there's maybe less information out there. Now I need to figure out how that file system works and get a full parser. And maybe I can actually create a utility that I can release open source that somebody else can use to parse that really old wonky file system for whatever reason. That's another way to get into the data structure aspect and the organizational aspect of the data, rather than going all the way down to the executable binary.
Yeah, we've kind of brushed against it. But so what I do is mostly binary reverse engineering, which can be applied to cybersecurity, but it can also be applied to all sorts of other things. So intellectual property protection, some people will actually reverse engineer other systems to make sure they're not using patented techniques, and or you might reverse engineer something to make it compatible. So for example, Apple has their iPhone that they release, and there's a protocol that the iPhone talks to with Mac OS and with Windows iTunes, but people wanted to make their own their own software that could talk to the iPhone. So on Linux, there's a ton of work on trying to make a libiMobile compatibility software layer that will allow Linux to talk directly to iPhones. So so that's another reason you would do binary reverse engineering, is to do this kind of protocol understanding, discovery, and compatibility generation. Yeah, so if you have legacy systems also, you could binary reverse engineer them to add functionality, and that might be a job. You could a task you would set yourself. Shelly kind of mentioned it too. Somebody I'm working with now has spent the last couple of years reverse engineering a game that he really liked, and he wanted to make it have a little bit more. So it's a mech warrior game where the idea is you're in a mech that walks around and shoots at things. So he wanted to have lasers and bullets act a little bit differently. He wanted to add some randomness to like spray, and as you're running around, changing how the damage worked and things like that over time. So he jumped into reverse engineering that game and expanding it in the different ways that he wanted to. And he learned all sorts of things about the encoding, the calibration data, and the mech configuration data that's in that game. So he's learned a lot, but he just sets himself little tasks, and then we work to try to achieve those.
Going back to careers, that can happen in a company. If you have somebody who wrote code a very long time ago, imagine code that is doing vast simulations, very specialized simulations, right? And you need to update it. The person who wrote it has retired. You end up in the situation just in normal companies too.
Yeah, sometimes you'll still have the source code for that product, and so you'll be able to reverse engineer at the source level, but other times you will just have a binary that was compiled, and you'll need to understand it and be able to modify it. I hope we're not droning on too much. Does anyone have any other questions, or is this?
I'm not sure if I missed what I'm asking. I'm not sure if I missed this, sorry. But like, what would the day-to-day look like while you're working for cybersecurity? Like,
I think you did miss it.
yeah, no, you missed it. Okay, sorry about that.
Yeah,
I'll
no,
look at-
but I'll go over it very quickly because it's worth touching on again because it's different depending on what you do. So what you've been hearing is, Chris does a lot of the binary reverse engineering, both static and dynamic. I do a lot of program understanding, so static tools to help with that. But that's a very, very specialized.
Sorry, just to interject there. So static meaning you're looking at the binary, but you're not running anything. And that's good for examining all possible execution paths. But then dynamic analysis is when you're actually running a system. And that's really good for understanding how a particular path or process worked, but it's not as good for understanding how all possible configurations could work.
So the incident response team looks at attacks against the network system in general and the hosts in the corporate network and says, what's going on day to day? Can I see if there are attacks that I need to be concerned about? And they go out and they clean up after them and figure out how to prevent those in the future. There's the information assurance who looks at day to day, what servers do I have running? What hosts do I have running? What is my network configuration? Can I get that set up properly? There's the flyaway teams who are like, they specialize generally in one type of system. So you could imagine like the power grid specialty people, right? So they go out to power stations when there are concerns there and they help sort of figure out what has happened, if something has happened, clean up and figure out how to protect in the future, and then go to other sites to make sure that that protection propagates appropriately. There's the sort of reverse engineering, which is understanding what programs are there and how they interact. There's the sort of threat intelligence, which is what are malware people doing these days and how do I sort of predict where they're going to go so I can develop detection and mitigation going forward. There's the research people. So Microsoft Research and Symantec do a lot of looking into how to tie the software, and Apple does this too, how to tie the software and the hardware together, just sort of designing new hardware and new software abstractions to try to reduce that. There's the reporting team. So Mandiant does this, which is, okay, now there was an incident, somebody went and got that data, they brought it all back, and now we're doing maybe weeks or months of looking into exactly how it worked, describing that in high detail. This is Google Project Zero as well, right? In high detail, and then describing mitigations for it. So those are some examples. I'm forgetting some too.
Yeah, nothing's coming to mind, but it's a very broad area. Yeah.
Could I maybe ask a question?
Yes, of course. Please.
Okay. But hopefully that's a long question, but like which, I guess, subfields of cybersecurity do you expect to grow in the near future?
Yes,
Yeah, so
something along with that. Both the Biden administration and also the European Union enacted in October of 2024 the need for critical infrastructure services to have cybersecurity. So to piggyback on this gentleman's question, how do you feel that might hopefully positively affect those who are seeking a career? Because at this point, it is not a nicety. All the critical infrastructure things, just like Colonial Pipeline 2 years ago, at this point, they're mandated to have a security stance, not just being nice to have.
Yeah.
it's true, but if you look at, so I'm going to get up on my high horse, my soapbox for a moment. If you look at how this is implemented these days, right? So NIST, the National Institute of Standards and Technology or something out of the US, has released something very cool called RMF, Risk Management Framework. Now, RMF is basically thousands of pages of documentation that says this is how you go in and understand your risk profile and your systems, and here are some suggestions for how to mitigate in your situation, and here's how you do this understanding. But a lot of the ways that people use RMF, even cybersecurity professionals who are not diving into the thinking about their systems well, is they pull up those lists and they start checking boxes. And that is not actually a sufficient risk mitigation strategy. So when you talk about, getting into the cybersecurity field and getting these jobs and the fact that they need to have people doing this, you also have to realize that there is a difference between a check the box exercise and an actual protection of your systems. And it's very difficult to tell the difference unless you are a cybersecurity expert who is thinking about it.
Is it because of how like variable and different every single cybersecurity issue is? So you can't really just say like, oh, it's like done and checked. Like you have to like case by case. Cybersecurity is very case by case, where you're saying, right?
It is that it continuously evolves. It is cybersecurity is an offensive defensive game, right? So the malware people, the adversaries, they are continually evolving as well, and so you can't have a static picture of what to do to make a thing cyber secure and count on that to last. You have to continuously reevaluate, as with any risk thing. Sorry.
Yeah. No, yeah. So it is a growing field. It is recognized that there's need for more cybersecurity specialists. Now, whether there's funding and budget for it, and what kind of things they'll go into, if it will be more of like a consulting, you bring somebody in externally to do your audits and make sure you're doing things according to guidelines. That might be a way that it grows. So
I will say a couple of years ago, the Department of Homeland Security said there is an 800,000 person gap between the number of people graduating with applicable degrees who could fill these roles and the number of roles that are going to need to be filled if there were infinite funding, right? So to me, that says if you go into research, if you go into your learning for cybersecurity and you do a good job and you differentiate yourself, it's not the need that is going to stop you from finding a job. It is the whether there's funding to fulfill this need.
And I think the legislation and the regulations could help, because we've tolerated companies losing data and having poor security postures for a long time, and it's more cost effective for them to pay off ransomware than it is to try to protect their system. And there's not really these costs associated to the company. And so I think if they start needing to pay insurance and there's these regulations, then I think the funding will have to come in, and they'll have to start hiring for it. It is something we like to say is that everything is computers these days, right? So phones are computers that talk to each other. Cars are computers that have wheels. Planes are computers that fly around. Spaceships are computers that go into space. Everything is computers, and so everything is cyber. There's a concern about whether it's secure, and then secure is such a weird term also, because you really have to understand what is your threat profile, what are you concerned about.
Every decision you make, you have to accept some risk. You have to accept risk. And right now, the way we look at cybersecurity in terms of those check the boxes is I'm not going to accept any risk. Well, if you don't accept any risk, you're not using your computer. Right? Or you're fooling yourself and you're just imagining that you're not accepting risk and you actually are. And so you're not seeing it. Yeah.
All right. So we just got the 10-minute warning from Zoom. So we have time for maybe one more question if there is one.
Okay. In a time where there's a lot of state-sponsored offensive cybersecurity groups, and it's a struggle between oftentimes like defensive and offensive development. Is there I've just been wondering about the ethical kind of idea that as like a cybersecurity professional, you're developing protection against the government of the country that you live in. And I don't know if you have any comment on that.
Yeah, I think that is a big concern. I agree. There is a trade-off. In general, secure systems are important. The government actually does a consideration also when the government is aware of some risk to their systems. they will let everyone know that like how to patch it and what the risk is. And
I'm going to take this in a completely different direction. If you think about structural engineering, the way we've built bridges over time, the way we've built buildings over time, and then you think about things like the Oklahoma City bomber, right? Who figured out how to use the structural aspects of the building to make it collapse in particular ways, right? That is the same kind of game. And in, you know, the way we do it, whether for the government or not, in my view, is just progressing our understanding and our ability to model the world. And so that is going to happen from somebody somewhere, no matter what. And, you know, because I believe in having systems that look at each other, including the government, like, you know, observes itself and keeps itself under strict control, I believe that the knowledge is necessary no matter what.
Yeah, that is, yeah, I thought as you started your question, I thought you were going to go in a path of sometimes there's a concern that doing defensive research could inform attackers of how to attack systems, and that is also the case. But I think knowledge is helpful, and you do have to be aware of how the knowledge that you're creating gets used. But I think that in general, I think it will be a better world if we have a more defensive security posture and we can trust the things that we are using.
If you look at the way the malware authors, and there were some really intense groups of malware authors kind of out of Brazil for a while, going back and forth with Symantec and Microsoft Research. And if you look at how they progressed each other, it was just this kind of ladder of climbing. But when Microsoft didn't release an update, a defense against what they thought would be a problem in the future, these groups would just actually sell effectively exploits that could be used against many, many systems. And so I like watching that sort of as a model for determining whether the defense, you know, whether the defense needs to be broadly released and make that decision.
Somewhat tangentially, but I'll just give an opinion. Historically, it has been the case that attackers were kind of in a privileged, in a better position because they only have to win once, was how the saying went. Whereas a defender has to defend against all possible vulnerabilities. I think we're understanding our security systems a lot better now, and we're ruling out entire categories of vulnerabilities. And so I think the defender is actually having an easier time now and becoming more on par with the
particularly with defense in depth, which has detection as well as mitigation at multiple levels. So it can only go so far.
All right. So is there anything, I think we're running out of time close soon. Is there?
All right. I think that is the end of questions, maybe because that's all the time we have. But thank you so much for coming here and talking to us and answering all of our questions. It's been really insightful. So thank you. It's pretty early where you guys are, so have a great rest of your day.
Thanks.
Thank you for inviting us.
This afternoon, I'm going to hop on a plane, so I'm actually going to be in Thessaloniki tomorrow. And if anyone wants to meet in person, I'm happy to.
Yeah.
Okay. All right. I will see you tomorrow. All right. Thank you.
You're welcome. Bye.